to start with a land acknowledgement from the sanctuary. And it is with gratitude and humility that we acknowledge that the Sanctuary for Independent Media resides upon the ancestral homelands of the Mohegan people, who are the indigenous peoples of the lands of New York and of the Hudson River. Despite tremendous hardships and being forced from their lands, today their community resides in Wisconsin and is known as the Stockbridge-Muncie community. We pay honor and respect to their ancestors, past and present, as we commit to building a more inclusive and equitable space for all. That's a sanctuary statement. It also applies to me, as where I'm sitting is also Mohegan land. And I also want to thank the people who have brought off this webinar and done a lot of work to organize it. I am part of the Clean Air Coalition of Greater Ravena Coeymans, and members of the steering group have helped put things together. But I want to thank also the Clean Air Action Network of Glens Falls, Beyond Plastics, the people of Albany United for Safe Energy, Food and Water Watch, Green Education, and Legal Fund. A special thanks to the Nature Lab and to the Sanctuary, and especially to Steve Pierce, Brenda Miller, and Sina Basilihicki, who have all been very, very helpful to us in getting this webinar organized. So thank you to everyone. I've been asked to be the moderator. I've lived in the Hudson Valley for about 11 years, 10 or 11 years. And I came here from London, where I was doing long range planning work after I finished my PhD at the University of London. I did a lot of work originally for Royal Dutch Shell in the 1980s. And I have been part of their discussions about how do you make an energy transition. I've worked freelance since 1987, and my clients have been both nonprofits and corporations. And I've done a lot of work in recent years on the energy transition in Eastern Africa and in Houston and in Pennsylvania. The thing to remember is that making the transition off of fossil fuels is not easy for anyone. The bill that we're here to talk about looks at one proposed solution, which is to try and capture carbon dioxide and other greenhouse gases, either from where they're being emitted or from the air directly. And our speakers are going to be talking about that. And they'll be telling you what they've learned about this technology and whether they think it's appropriate for making the energy transition and reducing our damage to the atmosphere. My assignment to begin with was just simply to summarize the bill that is before us. The numbers of the bill are, it's called the Carbon Dioxide Removal Leadership Act, A8597, that's the Assembly bill number, and the Senate number S8171. You can look up both of these bills very simply, just by putting in Carbon Dioxide Removal Leadership Act, and you can see what the bills actually say. The intent of the bill seems to be to establish a way for New York State government to pay corporations that are able to remove carbon dioxide from the atmosphere. The elements of the law, when you read it through, I added it up this morning, there are 209 lines of text. 65% of that text is about the definitions and the methodology they want to use, called a reverse auction, where corporations propose a solution to pulling greenhouse gases out of the air, and they say, this is how much it will cost you, New York State, to pay us to remove that greenhouse gas from the atmosphere. And the rules of the reverse auction are complex. They take up a lot of verbiage, and as do the definitions, because they're all tied up together. And that's kind of a normal part of any bill that's trying to do something. Then there's about 20% of the text that's proposing different possible removal methods, which our speakers will address and describe, and a few lines on how do you verify whether companies actually removed any greenhouse gases and what the penalties might be if they haven't lived up to their side of the bargain. A few other things about a legal phrase, severability, which I won't even try to explain. And then there's a scorecard of things where you can get extra points if you're making a bid to remove greenhouse gases, and you can get extra points if you show that you've been efficient in conservation terms, You've created long-term storage, you've respected the ecology, environmental justice, you've created jobs. All of this takes place in New York State. But the first thing that matters most is how much are you planning to charge for this service? So those are the elements of the bill. What I did notice as I read the bill was that there's no clear statement of what is the goal. We've been told that if you do everything you can to stop the emissions, whether it's shifting to electric cars or going in for lots of solar or whatever you can do to stop using fossil fuels, which means stopping emissions, all of that will take out 85% of the emissions. But there's a remaining 15% that's kind of hanging around the atmosphere every year, and you want to grab that as well. So the purpose of this bill, as I understand it, although it's not stated in the bill, is to go after that 15% that is not going to be removed by the methods we've heard about so often. But the target that they've set for themselves, I found extremely unclear. In the first paragraph, it says 15% of New York State's 1990 emissions need to be removed by 2050. As it is written, that adds up to 35 tons of emissions. And in the 25 years that this bill covers, from 2025 to 2050, if it's at all comparable to the past 25 years, you would get almost 6,000 tons of emissions being put out in New York State. So to take out 35 tons doesn't make much sense. So maybe, in fact, there was a typing error, and they meant to say in this bill, between 2025 and 2050, 15% of 1990s emissions need to be taken out every year. But if that's what the bill is supposed to do, if that's the target, it should be said so explicitly. On the other hand, there's another part of the bill that says departments shall establish what the targets are for the emissions that need to be removed in this carbon capture and storage and the direct air capture, all these methods that will be described by our speakers. The other thing that the bill doesn't mention is what's the expected cost and how much is New York State expected to pay? So we have a bill that has no clear goal. It has a target that is open to at least 3 different interpretations, and we have no mention of cost, but a lot of language about how the reverse auction would work, what the definitions are, and how you can get extra points by being a good citizen and respecting ecology and environmental justice. So that's what the bill is doing. I know that a lot of people believe that we will need to have some kind of direct air capture, that we've gone so far in the emissions that are in the air, we need some kind of technology to help us. The question in my mind, looking at this bill, is, I have 3 questions really. Is this the right approach? Is this bill the right approach? And you can read it for yourself and see what you think. Will it actually achieve what it says it's going to achieve? Will it be efficacious? Will it actually remove 15% of 1990s? Will it remove 35 tons of carbon every year between now and 2050, or even once? And in the face of the climate emergency, is this actually the best use of public money? And those are the 3 questions that I hope our speakers will help us to answer. We have turned off the chat while the speakers are speaking, but we will open it up again, and we want you to put your questions to the speakers in the chat once it's open. And in the meantime, if you can write them down so you don't forget them, that would be very helpful. And I would suggest that, given that there's a lot of information we'll be hearing, start first with what are the things you need to have clarified. So what are the questions that you want to have clarified? And when this is all over, we would urge you to phone your Senate and Assembly representative, and I'll give you their numbers, and phone Michelle Hinchy's office. Well, I'll give you her number. These are the people, she is one of the sponsors of the bill, and you can let them know what you now think of this particular bill. So with that, I am going to turn over to our speakers, and our first speaker is June Sekera, who's a policy scholar. She's a visiting scholar at the New School University in New York and a senior research fellow at Boston University. She began looking into carbon capture technologies about 4 years ago, And she spent a lot of time trying to understand what it is, what it says it does, whether it does what it says it does. And she will be speaking first for about 20 minutes. After she speaks, Jim Walsh will be speaking. He's the Policy Director for Food and Water Watch and Food and Water Action. And they both have two very, very interesting presentations. And I hope you will find them informative and will challenge us with whatever questions you might have. So make a note of your questions for now, and I will turn things over to June Sekera.
Thank you, Barbara, and thank you all for the invitation to talk to you today, and thanks to everybody who's here. I'm going to be doing a general overview of carbon capture and storage, and Jim is going to be addressing the legislation. So let me get my presentation up. Okay. Can everybody see that? Okay. So as I said, I'm going to be doing a general overview. I'm going to be contrasting the promises that we've heard with the realities. So there are several premises on which the promises are based. One that we've heard a lot about is net zero, and that is an assertion that we can catch our emissions and negate them, basically. And the second one is that the technologies that are being talked about will take carbon dioxide out of the air, and that it'll be done fast enough to have a climate significant impact, and the storage will be permanent. And the third one is that the captured carbon can either be utilized in some way in some product or safely buried underground. And all of those premises are false or dangerously misleading. So the realities of carbon capture, the methods that are being publicly subsidized in the United States right now are basically fossil fuel subsidies under the banner of climate mitigation. Many of them are increasing the level of CO2 in the atmosphere rather than decreasing it. And none of the methods that are being subsidized right now actually take CO2 out of the atmosphere, excuse me. They all bring enormous physical hazards and threats to public health, especially for frontline communities. So why doesn't it work as advertised? I'm going to go through what I call Carbon Capture 101, and I'm going to run through the three-part process that is carbon capture. I'm very sorry. Which is the CO2 is captured, then it's transported, then you have to do something with it. And I want to underscore that I'm talking about mechanical carbon capture and not biological sequestration. So let's start with capture. There are two types of capture, and one of them is to capture CO2 as it comes from the source, which is generally referred to as CCS or CCUS. Carbon capture and storage, or carbon capture, utilization, and storage. And the U for utilization, I should point out, was added a few years ago to CCS. The terms are really used interchangeably. The U was added because someone thought that a rebranding was necessary to make CCS sort of sound better if you can utilize the CO2. The other method is to capture the CO2 that's already in the air. That's called direct air capture. Both of these methods are industrial, mechanical, chemical processes. And I should underscore that they only capture CO2. They don't capture any other kind of greenhouse gases. No other kind of greenhouse gases are captured by these methods. So the reality is that all of the carbon capture projects in the United States at power plants have failed. And you can see the list of them on the right there. These projects, which were attempts at commercial projects, have received about $2 billion in public subsidies. And they've all failed or closed or been withdrawn. These are at power plants. A study published last year looked at 263 projects, CCS projects, pilot and demonstration projects globally. they found that the majority failed. Of the largest projects, 78% were put on hold. And they found, as you looked at the data, that the larger the project, the more likely they were to fail. And they also said that higher public R&D spending does not lead to successful deployment. This is a list of the carbon capture projects, CCS projects that are in operation in the United States right now. There's only a dozen of them. They are all direct source capture. They are all enabled by taxpayer subsidies. None of these projects would be possible without the tax. They wouldn't be happening without the taxpayer subsidies. This is a summary of these 12 projects. None is at a power plant, of course, because they all failed. All are smokestack capture, 5 at natural gas facilities, 3 at fertilizer production facilities, 1 at hydrogen production, and 3 at ethanol production facilities. None, of course, is a direct air capture operation. Important to underscore, none of these remove CO2 from the atmosphere because smokestack capture does not remove CO2 that's already in the air. So now I want to digress, go off on sort of a little bit tangent here onto DAC, because that's what people wanted to hear about and talk about the reality versus the vision. And in terms of reality, I want to touch on carbon, on energy consumption, land use, and hazards to crops and plants. There are 3 DAC companies in the world right now, as you see on the screen there. One of them is Carbon Engineering. That was started by money from Bill Gates and Occidental Petroleum and Chevron and some other investors in oil companies, and was started with a scientist at Harvard working with Bill Gates originally. The other company, Global Thermostat, operating in the United States, was started by 2 people, an economist at Columbia and a fellow at Columbia who's a former ExxonMobil employee manager, and the partnership there is with ExxonMobil. And the third company is Climeworks, and they're based in Switzerland, and I will talk more about them in a little bit. So what's the reality about DAC right now? Well, we are led to believe that DAC removes or will remove, when it gets to operating, CO2 out of the atmosphere. But in fact, DAC can increase the amount of CO2 in the atmosphere. And in fact, when DAC is fossil fuel powered, that's what it will do. It emits, one study showed that it emits 1.5 to 3.4 tons of CO2 for each ton that it captures. In fact, the largest DAC plant to be built in the United States, to be built in Texas. They have been planning it. It's been on the drawing board for about 3 years, and it's supposed to be starting, the groundbreaking is supposed to be this year. That's Occidental Petroleum using the carbon engineering methodology, their process. It's going to be mainly fossil fuel powered, natural gas. They say that they're going to, in addition to capturing the CO2 out of the air, they're going to have another CCS operation to capture the carbon dioxide that's emitted by burning the fossil fuels that they use to run the DAC operation. So it's a pretty much of a sort of a Rube Goldberg kind of an operation to capture the CO2 that you're creating by capturing CO2. All of the captured CO2 will be used for oil extraction. Every bit of it is going to be used by Occidental Petroleum for oil extraction. And the business plan for this DAC plant relies entirely on government subsidies. They are attempting to get private investors and having a little bit of success, but the business plan won't work without the public subsidies, which they are very willing to admit. Their aim is to capture 500 tons of CO2 per year, which is 0.0005 gigatons. So what's a gigaton? So I want to talk just a second here about scale. We are emitting, humans are emitting globally 39 gigatons, 39 billion tons of CO2 a year. Of that, 5 gigatons, 5 billion tons annually is the United States. So in the work that I've been doing recently and a paper that I'm working on right now, I talk about removing net removal of 1 gigaton of CO2 per year to have any climate relevant impact. And you can see the white circle there representing the 1 gigaton per year. So let's look at the brown circle, which is the CO2 emissions by the United States, and let's look at what mechanical carbon capture is doing. Mechanical carbon capture is removing 0 CO2 from the atmosphere. That's because it's all that's going on right now in the United States is smokestack capture. That's removing 0.02 gigatons a year, but it's being used mostly all for oil extraction, which puts more CO2 into the air, which means there's no net capture, much less removal out of the atmosphere. The amount being removed from the atmosphere is 0. DAC, how about energy consumption and land use? So this is a bubble diagram that represents the energy consumption that would be required by the Occidental Petroleum, by the carbon engineering methodology to capture 1 gigaton of CO2 per year. It would require an amount of energy that is almost equal to the amount of electricity generated in the United States in 2017. That's how much energy it would take for this process, which is called it's a liquid solvent method of carbon dioxide capture. Well, what if it was powered by solar instead? Well, if the DAC process that we're talking about here, this liquid solvent process was captured by using solar power, then it would require a land area 10 times the size of the state of Delaware. And then there's the toxicity issue. Chemicals is how CO2 is captured, called sorbents and solvents. And this is a list of some of the chemicals, lye, and the chemicals that are used to capture CO2 and that are used to produce the chemicals that are used in the capture process. They all pose hazards for workers and for frontline communities. And there's an issue that hasn't been looked at hardly at all by people writing papers about direct air capture. And what is the downstream dangers? What happens to the residual waste of these chemicals? Where do they go? And are we going to be confronted at the gigaton scale of a hazardous a waste removal and waste disposal problem like we have for nuclear waste? And there's also another kind of toxicity, which is toxicity to habitats and crops. When you have large arrays of DOC, you have what's called CO2 depletion zones, and that means that could affect crops and harm or kill crops. This is pointed out in the National Academy of Sciences report on negative emissions technologies. What's the vision? So the legislation is of course about a vision. This is one of the visions that's been in the works for a long time, called mechanical trees. There has been experimentation and lab work on direct air capture since about 1999 of various methods. Obviously, none of them have come to fruition except for the ones that I've talked about. The only one that's being planned at any scale is the carbon engineering one. The other method, which is the solid sorbent method, is used by Climeworks, and you may have seen a lot of the publicity from last year when their Orca plant was announced in Iceland. There's a picture of it, and as one climate scientist said, that plant will in a year capture 3 seconds worth of humanity's CO2 emissions. To get 1 gigaton capture with this method, this Orca type of carbon capture plant would require 250,000 of these plants. And this is important because the US Department of Energy has given money to the University of Illinois to do a DAC development and demonstration project, which is going to be siting those sorts of DAC plants in 3 states, Louisiana, California, and Wyoming. Their goal is to, by 2027, reach 0.0004 gigatons of removal per year. That timeline there, that's 18 years from the time that Climeworks started to when they hope to reach that goal of 0.0004 gigatons. They say 400,000 gigaton. They say 400,000 tons because of that. Of course, that sounds impressive, but it's actually not consequential. I want to for a moment mention biofuels because biofuels is mentioned in the legislation. There's something called bioenergy with carbon capture and storage. Basically what this is you grow crops, you make fuel out of them, and then you burn it, like corn ethanol, for example. And it just so happens that a study came out last month about corn ethanol production in the United States. That's a title from a Reuters story saying US corn-based ethanol is worse for the climate than gasoline. This study found, this study by Lark et al. This year says that the energy intensity of corn ethanol is 24% higher than gasoline. And that is just ethanol production. That's not even counting the extra emissions that will be happening with the CCS process, because the CCS process will use additional energy and have additional emissions and be more energy intensive. So let's move now into what to do with the CO2 once you've captured it. There are three choices for what to do with the captured CO2. One is to inject it underground for storage. One is to sell it as chemical feedstock, and the other is to sell it for oil extraction. And this is that same chart again. And in the United States, what's happening is that the captured CO2 is virtually all being used for oil extraction. And the only one that is not being used for oil extraction at is the one on the bottom there, which is the ethanol facility in Decatur, Illinois. That facility actually, although it's capturing and putting its CO2 underground, the overall plant emits 8 times more CO2 than has been buried. All of these, including the ethanol one, have been enabled by taxpayer subsidies. So what is enhanced oil recovery? EOR, which you'll be hearing a lot more about probably, is a method that's been around for quite a long time in the oil industry, by which CO2 is pumped into existing partially depleted oil fields, and it pumps the remaining carbon dioxide out from that oil field, and leaves some of the CO2 underground. The New York bill appears to ban EOR, but I would urge you all to make sure that the ban is not deleted as the bill goes through the sausage making process. So moving on, according to my roadmap here, let's go to transporting it. And this is, of course, mechanical methods. I'm not talking about sequestration by biological methods. Pipelines. I just wanted to show you all the projects that are going on now in the Midwest in 6 states. You can see up there in the upper left-hand corner. There are 2 companies. They're actually new pipeline companies that were formed for the purpose of building these 3,500 miles of pipelines across these 6 states in order to take the carbon that will be captured from ethanol facilities, ethanol plants, and fertilizer plants, move it around and put it underground in North Dakota and in Illinois. They first said that they were going to use the captured CO2 for enhanced oil recovery, but now they're saying that they're not so sure. But importantly, as they're going through the process, they have announced that if landowners and farmers that own land don't provide the land voluntarily for the pipelines, it will be taken by eminent domain. They've applied for the ability to use eminent domain to take the land for pipeline building. I just wanted to show this because this is a slide that was used in a presentation 2 days ago to the Minnesota Public Utilities Commission by one of the groups that's working to push this project in the 6 states. This is the Great Plains Institute vision of pipelines for the United States under capture and storage under 45Q, the federal tax credit. This is another vision of pipelines across the United States. And as you can see, by the way, they do go into New York. This also goes into New York. This is from a report by Princeton University called the Net Zero America report, which was largely paid for by funding from BP, the oil company, and they envision a pipeline that looks like this for less than a gigaton of capture, about 66,000 miles of pipelines for less than a gigaton capture per year. So how do you transport CO2 through pipelines? You have to pressurize it, and in natural gas, and much more highly pressurized than natural gas. You can see the pressurized, the PSI pounds per square inch required for natural gas, and CO2 is 3 times or 2 times as high as the pressure required for natural gas. This is a picture of an actual compression station at that ADM facility in Illinois, the one I was talking about a minute ago. This is what their compressor facility looks like for their CO2 compression. If the CO2 is going to be transported through pipelines like the ones that we saw on those maps, you have to have compressor booster stations along the way to keep the compression going and to keep the CO2, which has to, by the way, be compressed into a semi-liquid state. That's why you need the compression. And so you have to have plants that look like this all along those pipelines. As someone said, what we're talking about doing is building a publicly financed sewer system for the fossil fuel industry. And as if that's not enough, there are a lot of hazards. This is a picture of the beginning of a video of a controlled experimental release of a rupture of a CO2 pipeline. That was done to find out what would happen if there was a rupture of a CO2 pipeline, and it was a controlled rupture. And you can see how that the CO2 spreads. It spreads for miles almost instantly. This is a pictures of a real rupture that happened in Mississippi, CO2 pipeline rupture in 2020. And if you haven't read it yet, you should. The gassing of Satartia in the Huffington Post by Dan Ziegart. He did a marvelous job on this story, explaining what happened. 43 people were sent to the hospital, 300 were evacuated, people were found foaming at the mouth. This was a mile from the rupture site, which you can see in those pictures there. Again, that sort of telltale white stuff from the carbon capture that's escaped rapidly from the rupture. So you've captured it and you've transported it. Now you have to do something with it. So the 2 choices here are utilization for products or processes, or injecting it underground, burying it underground. I'm not going to talk about utilization because utilization is immaterial. Utilization for any use is irrelevant in terms of climate significant scale. And Jim is going to, though, talk about utilization and more of the problems with utilizing captured CO2. What I want to just briefly talk about as I rush to get to the end here, because I'm over time, is underground storage and its risks. Basically, you have the issues of leakage, blowouts, earthquakes, groundwater contamination, and more. This is a list of actual leakage, blowouts, and ruptures that have happened, even with the tiny bit of capture that's going on. And these are events that happened over the last 10 years, the last one being the mass casualty event in Mississippi that I showed you the pictures of. This I just wanted to show you, there's very little written about the risks and the dangers of CO2 capture, injection, storage, et cetera. This happens to be from a study, a report, a handbook by the Department of Energy, overview of potential failure modes and effects associated with CO2 injection and storage operations in saline formations. Saline formations is one of the target kind of formations for underground storage of CO2. I'm certainly not going to try to explain that picture, but I just wanted you to show you that there is a handbook that does go into this. And this is another page from that handbook that lists one page of a very many pages of all of the various hazards from underground storage, injection storage of CO2 in saline formations. So I just want to stress that leakage, rupture, contamination, asphyxiation can all happen from CO2 capture, compression, transport, injection, and storage. Contamination of underground, of groundwater formations, including drinking water sources, movement of that salty water in those saline formations, gradual leaks into the air, which have happened and actually caused evacuations, sudden large accidental releases like that one that happened in Mississippi, and earthquakes induced by injection pressure and also underground storage, because when it's underground, when it's stored underground, it's under very high pressure when it's stored underground. CO2 in high concentrations is an asphyxiant. It displaces oxygen. In a rupture, it lies close to the ground. It's denser than air. It displaces oxygen, and you can see the concentrations there and what happens to people and animals at these concentrations. And in Mississippi, when that pipeline burst, as much as a mile away, people were violently ill. They were hospitalized. Some of them are still ill. They had lung illnesses and damage that is still going on. Their cars were stopped because internal combustion engines can't work without oxygen. And so when this bursting of the CO2 pipelines happens, the cars die. And so the first responders had to break car windows open for them to get to the people who were injured by the CO2 and unconscious from the CO2. And the first responder vehicles, some of them, I think, conked out. And in a large mass casualty event, first responder vehicles are not going to work. Then there are the legal and liability issues, eminent domain for taking of land for pipelines and storage, the permitting of the pipelines, the ownership of so-called pore space, which is another name for the underground storage space, the legal and long-term liability issues, which by legislation that's being proposed, and I think actually passed in Louisiana, the long-term liability is being transferred to the public, to the state, and to the localities, and the liability for these mass casualty events that are certainly bound to happen. This is just a picture to indicate that 13 oil companies formed something called the Oil and Gas Climate Initiative, OGCI, back in 2019. It was started. It's a global initiative. And I want to briefly mention an alternative, biological sequestration. If we indeed, if legislatures indeed are convinced that we need to remove CO2 from the atmosphere, there is biological sequestration via ecosystems in forests, farming, grasslands, and wetlands. And let's go back to that bubble of the 5 gigatons of year that we are emitting right now in the United States of CO2. And remember that we are removing 0 CO2 from the atmosphere now with mechanical methods. Right now, biological sequestration in the United States is removing almost a gigaton. That's net removal. That's just the biological trees and grasslands and wetlands and et cetera that are seagrass that's removing CO2 on net in the United States right now, and with hardly any extra land use but improved practices and restoration of those biological systems in forests and grasslands, et cetera, we could fairly easily be removing 2 gigatons, more than 2 gigatons of CO2 per year, while we're still capturing for probably a very long time 0, almost 0, next to 0 through mechanical methods. And I want to stress too that biological methods are not going to work when they're financed by carbon offsets, because the offsets and the carbon credits undermine all of the sequestration, just about all the sequestration that goes on through straight biological sequestration. If we're talking mechanical methods, we would need to have a wartime scale of effort, a wartime build out for climate significant impact of mechanical methods. That term, wartime scale of effort, has been used in a number of studies looking at what it would take to build up DAC to a climate significant impact. One study says that would require probably $1 trillion a year. The problem is global. The perils are local. Communities lose control, they lose wealth, they suffer the physical hazards and health harms. Eminent domain, risk bearing, I've mentioned all these things before, value depletion, lack of control with this pipeline permitting that's going on, for example, now in the Midwest. What's the real alternative? Stop putting human-caused CO2 into the air. And that's the conclusion of my presentation.
Thank you very much, June. I'd like to turn things over to Jim Walsh now, and he will be speaking for about 10 minutes. So if you can be a little bit patient, you'll get another perspective on this, and you can make your own minds up about what you think about it. Jim, over to you.
Great. Thank you so much for having me, and for Media Sanctuary for putting this great event together and giving us an opportunity to talk about this. I'm going to talk really about carbon utilization. And one of the things that, really struck me is listening to June's presentation. She talks about really well and succinctly about kind of where things are with carbon capture and things like that. And due to the work of June and other people, there's been a lot of education going around about the problems with carbon capture in general. And I look at this bill as an attempt to rebrand carbon capture and repackage this technology that is not been working well, and we have no reason to believe will work well. But I also, in this, want to also stress that with all of these technologies and things we're looking at, one of the things that industries, and particularly the oil and gas industry and other polluters, want to do is to narrow the focus of what we're talking about as much as possible, so that you're only looking at one little piece of the puzzle that they have, and you can't see the full picture of these impacts. And so it's very important that we look at the full picture of these impacts when evaluating them, and not just these, the dynamic where the industry will talk about it. Oh, well, we remove CO2, so it's good. And so, well, and the questions that June asks is, well, how much CO2 are we removing? What are the land use and energy impacts of that? And these questions need to be asked about this rebranding of carbon capture as well. And I think one of the things I want to start off with here is in preparing for this, I had a conversation with Judith Enck, who's a former EPA administrator. And, she said, this is the worst bill introduced by a Democrat in New York State legislature this year. And that is hard to disagree with her on that point. This bill is very concerning. And one of the reasons it's very concerning is because of the whole concept of carbon utilization. Because carbon utilization is about creating dependency on CO2. It's about creating a whole economy based on the utilization of a waste stream from the fossil fuel industry, and creating profit incentive and value for that waste stream. And so if you create value for CO2, the ability to actually get rid of it out of the economy becomes very difficult, because you're going to have entire industries set up ready to work and develop CO2 products and other sorts of things from CO2. And so we need to be very, very cautious of these calls for creating markets for CO2, because once you put them in there, it's very difficult to get rid of these markets once they're created. It creates more dependence on emissions. And it also, when we talk about emissions, it takes the focus off the other problems of greenhouse gas emissions. This is looking at the bigger picture. And so when we take the focus off of greenhouse, or we take the focus off the other problems, we're ignoring the impacts of fossil fuel extraction, like fracking. We're ignoring the impacts of pipelines, which June talked about significantly, and all of these other air pollutants, which primarily harm disadvantaged communities that tend to be near the sources of industrial and fossil fuel pollution, which is the real cause of the climate crisis that we're dealing with. And so when we're talking about addressing the climate crisis, if we're not talking about stopping new fossil fuel infrastructure, and we're not talking about phasing out the existing fossil fuel infrastructure, then we're having the wrong conversation, because that is where the problem lies and where we need to address it. And stop really looking at these faulty assumptions that are being put forward by the oil and gas industry and other petrochemical companies that are pushing these technologies forward. And so this bill, really, when I look at the things that the bill does with utilization, I can put them into these four buckets that I look at, and it's geoengineering, this idea of biofuels or biochar and bio-oil, the development of construction materials like concrete and plastics. And these are really the places where this bill proposes to put a lot of these things from going forward. And I'll talk about that. There's very little to believe that those first three options are actually going to be something the industry goes forward with in any meaningful way. If they do, it'll be problematic, and I'll talk a little bit about that. Where I really think they're focusing on is that last bullet, plastics, petrochemicals, and also, which is not explicitly in this bill, but is really the camel's nose under the tent, which is the larger new sort of advanced fuels, as the industry calls them, that are being created. And so under the geoengineering utilization skills, there are schemes, there's processes like, you'll hear things like mineralization and weatherization. Ocean dumping is something else. They don't call it that, but that's what this bill calls for. And fault injection of CO2 and various other schemes. And so when we think about geoengineering, what this is really taking Earth's natural processes and trying to supercharge them in many ways. And so that's doing things such as taking rocks like silica, which can naturally absorb CO2, and smashing them up and creating more surface area to capture more CO2. We talk about ocean dumping. They use much nicer words for it, but that's what it is. It's taking raw minerals and other materials that we can actually put into the ocean to decrease acidity so that more CO2 would be absorbed. Injecting CO2 directly into faults is something that that proponents of carbon capture have suggested doing in this bill as well, in general with this process. And this can create a lot of unforeseen consequences. When we think about the aspects of like putting a bunch of minerals in the ocean to change acidity, this can have a lot of impacts, and particularly when we're mining those minerals, or potentially using the minerals as a byproduct from various industrial processes. You're actually taking industrial waste and potentially dumping it in the ocean, which can cause significant problems. The mining of silica or other minerals is a dirty process. You're going to need the pipelines to transport the CO2 once it's captured. These things are also very slow to scale. And so if you want to speed them up in the process, what's speeding them up takes energy inputs to create more heat and pressure so that these things like silica and things like that could actually absorb more CO2. And that takes energy inputs. And when we look at the full picture of this, that can actually create an environment where we're actually increasing overall CO2 emissions, because we're considering not in the discussion, we're not considering the upscale or upstream emissions and the downstream emissions that come from mining or transporting CO2 through pipelines that leak. We're not discussing the co-pollutants, and we're not discussing the real questionable efficacy of these processes from being moved forward. These are all really in a very experimental phase. And so we're talking about investing significant resources in something that we're not really sure will work well, and has really questionable reasons to question the efficacy of these processes. There is the development in this bill of biomass, biochar, bio-oil, BECCS. And BECCS are something that I'm personally and organizationally are really egregious. It's bioengineering with carbon capture and storage. And this is the idea that we can essentially take a biological source and burn it and capture the CO2 emissions. Or in the case of biochar and bio-oil, actually take organic matter, biological matter, and create an oil or essentially charcoal by heating, by creating a high heat, low oxygen atmosphere, also known as pyrolysis, to create these sorts of things, which takes energy inputs. And can be very concerning, and biomass, which is generally chopping down forest or taking agricultural residue and burning it. And then proponents would propose to capture the greenhouse gas emissions and do all the horrible things that they could potentially do with them. And so these are all very concerning processes when looked at in the full picture of what we're talking about in this bill. And when we're taking, for instance, we're taking biochar. There's, one of the things that biochar can come from municipal waste treatment facilities, sewer plants, and they'll take the waste from those facilities and put it through a biochar process and then spread it on soil as a soil amendment. And this is very concerning because if we're finding things like PFAS in our waste products, which can from publicly owned treatment works, and then spreading that on soil, which can impact agricultural production and other toxins and harmful contaminants that can also be put in those areas. Or there's also proposals to actually take biomass and sink it to the bottom of the ocean, which is something that would be promoted by this bill. The impacts of taking large amounts of biomass and sinking it to the bottom of the ocean could be detrimental to life on the bottom of the ocean, which we know relatively very little about. And we don't know how that can actually impact other layers of the ocean moving up. And so these are really important questions that need to be asked before we embark on it, even consider embarking at any of these things about the problems associated with these sorts of technologies. And so I just talked about some of these problems with these sorts of things. The emissions from burning competes with food production. This is something particularly concerning with BECCS. We're looking at tremendous amounts of corn being turned into ethanol. In the Midwest right now, the pipelines that June had talked about are being built for ethanol production right now. And ethanol production itself actually creates a dynamic where we're competing with food production and energy use or climate protection. And this can create issues and challenges with commodity markets and pricing, and also land availability for growing these various products. As energy or carbon capture gets value, the value of croplands for other foods, it has to compete with that, and this other value could become more valuable to industries. So then you could squeeze out some of the food production areas that actually exist. And there's a lot of uncertainty about all of these things. So the people who promote this talk about these things as though they are really great, wonderful, and everything's figured out. The reality is there's tons of uncertainty about all of these technologies. The concrete and CO2 is one of the things that a lot of proponents of carbon capture utilization in particular talk very highly of. In reality, the concrete and CO2 can actually result in worse outcomes. But what they do is in the production of CO2, you'll have emissions that come really from two sources: the heat that's necessary to actually create the concrete, and emissions from chemical reactions. And what the proponents are doing is actually proposing to inject CO2 into the concrete production process to actually bind the CO2 with other rocks and minerals in the production of concrete. And this is really met with really questionable results. There's a really great study on this by the gentleman at the bottom, and I will not do injustice by mispronouncing his name or her name. But the concerns that they raise there is really that there's that depending on a number of factors, we can actually see CO2 injection into concrete actually overall increasing the emissions of CO2 in the environment. And they looked at a number of different studies and models of this process and found over half of them actually found increases in CO2 because of various things about how the CO2 is produced, issues with the curing process and what's done in curing the CO2 and the production of CO2. So there's really significant life cycle emission concerns. And with all of these things, they require pipelines to transport the CO2 from where it's captured to where it's going to be utilized. And so we're going to see pipelines with this as well. Their real plan, this is where the industry is really going with this. Right now, as June pointed out, enhanced oil recovery is what they're using it for. It's this process to increase oil production at wells that would otherwise not produce. But what their real plan is and what they're going for is opening up these markets to turning CO2 into plastics and new combustible fuels. And I don't see them stopping using it for oil extraction in any way, shape, or form, but they're really looking to do this with these new combustible fuels and through petrochemical development and refining into plastics. And in the bipartisan infrastructure bill that passed last year, this actually provides a lot of financing and money for these new petrochemical fuel production and support. And so the industry pushed very hard federally for that money and got it and is lining that up now. And they're really working to build the infrastructure to capture the CO2 they need to build this new infrastructure out. And the real plan and what we need to do is what I alluded to in the beginning. We need to stop new fossil fuel infrastructure. We need to phase out fossil fuels quickly. We need to push for electrification like what happened in New York City. We need to increase energy efficiency. That's like one of the biggest things we can do to have the biggest impact as quickly as possible is push for increased energy efficiency, like weatherization of people's homes to create more secure environments where you're seeing less heat leave in the winter and less cooling leave people's homes in the summer. And we need to end single-use plastics, because creating plastics by manipulating CO2 into a new petrochemical feedstock is not going to get rid of any of the problems with plastics. The plastics industry will talk about it that way, as though we can actually create these plastics without fossil fuels. Isn't it great? Well, the problems with plastic are definitely linked to fossil fuels, and there are significant problems with that. But there are still problems with refining CO2 into these new chemical feedstocks and the pollution that comes from refining those feedstocks into plastics, which primarily are located near disadvantaged communities of people of color, and low-income communities. These single-use plastics are finding their way into our oceans and into our rivers and streams. They are littering literally beaches around the world and filling up our oceans with microplastics. We are finding plastic in our drinking water. We are finding plastic in the air. We are finding plastic in our food. These are significant problems that don't go away because you create plastic out of CO2. They just compound the process and allow the industry to greenwash themselves with this new, fast, exciting new process, which is questionable on its efficacy, has a significant large-scale impacts that will adversely impact public health and our environment, and really distract us and move us away from the real solutions. The money that is spent on this by our public institutions is money that's not spent on the real solutions. So we need to stop new fossil fuel infrastructure, stop the funding and financing of these fossil fuels, and make the investments necessary to rapidly phase out fossil fuel development. And so I think we're going to go on to questions now. So thank you all very much for your time. And for those of you who put this together, I greatly appreciate it.
Thank you very much, Jim. That was very comprehensive. And I'm going to open up the chat, or rather, Steve Pierce will open up the chat for us. And please put your questions in there. I hope you've made a note of questions while our speakers were talking. And I had 3 questions, which is this the right approach at this time? Can these methods actually remove CO2? And in facing the climate emergency, is this the best use of public money? My quick impression from both your talks is that you would say not the right approach. It can't do what it says it's doing. And it's probably not the best use of public money, but maybe you can speak for yourselves. June, what's your answer to those 3?
The problem that I didn't recognize at first when I started working on this, but then I realized was the biggest problem, is scaling up. You can do all sorts of things in a lab, and that's sort of what the New York bill seems to be promoting in a way. We don't know who, if the bill were to pass, we don't know who would show up at the door with their proposals, but a lot of it will be fossil fuel industries. But beyond that, there'll be a lot of people with all kinds of ideas. But there's been lab work going on air capture since 1998, actually. And to scale up any any method that might be presented to the state of New York by a proposer in time to have a climate significant impact is, from everything I've studied, is likely to be a fantasy. There's just almost no way. I mean, the Climeworks plant that they started in, 2009, and they're at 3 seconds worth of capture per year. 3 seconds worth of our emissions captured per year. So I think the scale issue is one that has to be very, very, that people need to understand, and we need to talk more about.
Yeah, Jim, what's workable, right approach, cost effective, good public policy? You didn't
Can I just say no?
Absolutely. But here's a question. Oh, someone asked, could you explain what you mean by the reduced performance of concrete that utilizes CO2? And can you explain the findings of the Ravi Kumar study that you cited?
Yeah, and I'll actually drop a link into chat of that study as well, so that people can read it for themselves. But they really looked at a comprehensive look at a number of different studies and modeling into this idea of concrete production and how we can how effective it is at CO2. And their conclusion was it's really inconclusive, and there are definitely methods that are demonstrated to show that we will increase CO2 emissions. And one of the things they really talked about there in that study, I think is really important, is the curing process can actually, depending on how that's done, can actually create more emissions of CO2 being released from the concrete in that process. And even there's certain biological and other sorts of things that be going on that may impact the ability of that curing process to be done in the most ideal way that would be necessary for CO2 capture in concrete. And so, I think that, what we're looking at here is there's a lot of distractions here. We have the technology to actually address the climate crisis, to transition our economy off of fossil fuels. And it's cost effective. It'll be cheaper for us to make investments in clean energy than it will be to continue extending a lifeline to the fossil fuel industry and pretending like these negative emission technologies will work. And so we have the ability to build out the energy infrastructure that we need. We just need the political will to do it. And so this is a distraction from that political will.
Okay, I have a question, another clarification question, June, for you. Can you explain what a CO2 depletion zone is, and how does that affect crops? Yeah, this was in that direct air capture picture you had that might affect crops around it.
There's very little written on it because, well, I won't go into the because, but what I've read is about and heard about is that the issue is that when you have these big arrays, I can go back to my picture, but you have these the big fans. I mean, these fans in these DAC plants each fan is about the size of a jet engine fan. And you have to have, hundreds of them at any given facility. And then you have to build a bunch of facilities. You have to stack them up in an area over many, many acres. If you're using fossil fuel to power it, you're not using solar. Your main usage is the land for the plants, the factories, I should say. And it sucks all the CO2 out of the air, so it depletes the CO2 out of the air. So there's sort of two problems. One of them is that, as the original granddaddy of DAC pointed out, you have to be careful about siting these DAC capture facilities close to each other, because if they pull the CO2 out of the air, that there's not enough for the other factory to pull out of the air. But altogether, what happens is they deplete the CO2 out of the air, and CO2 is used by plants in photosynthesis. So plants will won't grow as much, or they could die. They just they'll be harmed by the depletion of CO2.
Okay, thank you. I'm just trying to, lots of very learned.
One thing I would like to do is somebody in the chat had said that the bill does nothing with plastics. And I just would like to just share real quick the section on the bill that does specifically deal with plastics, because I think there's a lot of misinformation going on around there. And so I would like that person who made that comment to know that it's absolutely in this bill. It is there, and it is a major part of what the industry is pushing to do. And so if I could I just do that real quick?
Let's do that quickly. Yeah.
Thank you. And so you'll see right here, direct air capture with durable geological sequestration, utilization, built environment, including long-lived plastics, carbon factors, and other durable goods. I think it's very concerning.
Thank you.
Thank you.
Someone else, June, said that there are lots of, many companies are trying to develop DAC, and you only mentioned 3 of them. But apparently there are lots of smaller companies that are doing this.
Yeah, there's lots of smaller companies that are in the lab stage.
Okay.
But there's only 3. What I should have clarified. There's only 3 that have well, there's only 3 large ones, and Climeworks is almost to the commercial stage. I mean, Climeworks is at the commercial stage. Carbon Engineering is almost at the commercial stage. And the other one, Global Thermostat, is sort of not really operating much now. And then, yeah, there's a whole, series. I mean, people like Elon Musk and all kinds of people are funding efforts. So there are, I don't know how many, lab pilots going on.
Yeah, there's a question here. Will panelists be sharing their slides and the sources of all the facts? I know that there will be a recording made available in a few days by the sanctuary. So they will be on there, and your references, I think, are often on your slides. Is that not so?
Yeah, most of my references are right in the slides.
Okay. So if you wait for the recording, you'll be able to see what that is. People have said, well, solar and wind were also a fantasy 30 years ago. This might seem like a fantasy now. Are you saying that the technology might not be developed, or it's just not going to be quick enough for the climate emergency we're facing?
So the biggest issue is the scale issue, getting it up to scale to have a climate significant impact in a generation. But you see this analogy to solar and wind a lot in the scientific studies and in the materials that are all around us. There's a huge difference in the development of solar and wind. I mean, basically, the only way to actually net remove CO2 from the atmosphere is to take it out from the atmosphere and put it underground. If you use it in products, those products like fuels, they're going to be burned. There won't be a sufficient demand for products. So the only way to really, if you did decide to scale up some form of DAC, over 30 years or whatever, and you wanted to do that, you would have to bury it all in order to have real net removal from the atmosphere. The thing about comparing that to solar and wind is that there's no customer when you're burying your product. So if you're capturing the CO2 and you're burying it underground, there's only one way to pay for that, and that's collectively government. And that is why, in fact, virtually I think every single paper that you read about carbon capture, DAC technological methods for removing CO2 from the atmosphere, talk about the fact that it needs government funding. And it does. If it's going to work, it needs government funding, because unlike solar and wind, when you're producing energy and somebody buys it, there is no customer when you're burying your product.
Right. There's another fact check here, Jim. No mention of ocean dumping. I think that's for both of you in the bill.
I can screen share the bill as well.
Okay.
And point that
Maybe
out.
they don't call it that, Jim, in the bill.
But yeah, what they call it is marine-based CDR, including electrochemical, carbon capture, alkalinity enhancement, marine permaculture, deep ocean sequestration of biomass, and coastal enhanced weathering. And so not all of those are ocean dumping, but a number of them are, particularly dumping biomass into the ocean is definitely ocean dumping. I don't know what else to call it.
Well, here's another question which strikes me. Once we've reduced all our emissions, how do we remove the legacy carbon? And what would you pay for if you were the person holding the purse strings?
So the Earth naturally absorbs carbon, right? The problem is that we're continuing to put more carbon in the atmosphere than the Earth naturally absorbs. And that is having significant impacts on our climate and our environment. And so we don't need to do these risky, unproven things. What we need to do is actually make the investments we know will work. Somebody made the comment earlier that 30 years ago, solar and wind, weren't as promising as they are today. That's absolutely right. They are promising today. And so rather than sitting here and focusing on building a new sector of our economy that's really based on creating a waste product from, as June had said, the sewer system for the fossil fuel industry, what we should be doing is actually building out the clean energy infrastructure that is necessary for this. We need to ban fracking like New York did all over the place. We need to stop these sorts of new infrastructure for fossil fuel development. And we need to invest in electrification. We need to invest in energy efficiency, and we need to invest in the clean energy to move our economy off of these fossil fuels.
So, but I think I take your point. If we invest in getting away from fossil fuels completely, there's still the emissions that have already been brought into the atmosphere from underground, the legacy emissions.
That's right. The Earth will naturally draw those down. If we stop spewing more CO2 in the atmosphere, then the Earth would naturally draw down.
Okay, so
and if I could add, the research that I've been doing, some scientists that have been helping me in the last year, who specialize in biological methods, I was very surprised to see the capability of biosystems to sequester carbon. And then you have all of the additional benefits, the co-benefits that you get with biological sequestration. So what people need to understand is there's two reasons why we have excess CO2 in the atmosphere. One is fossil fuel combustion. The other is ecosystem destruction. There's two causes. And ecosystem destruction has been going on along with our fossil fuel combustion. Certainly the fossil fuel combustion is the main cause. But the ecosystem destruction, the Amazon, we read about this all the time. If we keep destroying these ecosystems, we are destroying the ability of the Earth to do what it needs to do, the land and the oceans. And it is really quite impressive, as I showed with those bubble diagrams, the amount of sequestration, extra sequestration that could be accomplished by some fairly straightforward methods of biological sequestration. Now, that's not going to solve the problem overall, but certainly compared to the damage and destruction and mass casualty events that will assuredly come from, and the taking of land and the eminent domain that will assuredly come from the mechanical methods, what we need to do is to put more direct funding, not carbon credits and offsets, into the biological methods. And then, as Jim said, and as I stressed before, stop putting so much CO2 into the air and switch to and transition to non-carbon fuel sources.
Now, I'm told that we should be winding this up at about 8:15, and it's nearly 8:20 by my clocks. So I think I would like to thank you both and wind things up. According to my chat line, it says there are 99 new messages I haven't read yet. So I'm not sure we will, even if we kept going till midnight, whether we'll cover all of the comments that people have and questions they have.
Barbara, may I ask if you,
Yeah.
could your organization technically just save those questions? And they would certainly be helpful to us as we move
Yes.
forward, and I think to you too.
Yeah, I think that I would endorse that, and I rely on the sanctuary's technicians for knowing how to do that, because I'm afraid I'm a little bit of a Luddite on this stuff. So let's hope I'm hoping we can do it, and I think we can save. I can certainly save them on my laptop right away, and just save the chat. But in the meantime, I'd like to thank both Jim and June for having explained their point of view on all of this. There have been comments about why don't we have the defenders of the bill speaking, and maybe we can arrange another opportunity for that. But in the meantime, thank you both very, very much for your presentations. And for those of you who've been convinced by what they're saying, I would like you to get in touch with your own assembly member and your Senate member. You can ring them. The assembly switchboard is 518-455-4100. 518-455-4100. You can phone the switchboard and ask to be put through to the office of your assembly person, and then they will take your comments on board about this bill. In the Senate, 518-455-2800. That's the switchboard for your senator, your state senator. Phone them and let them know what you think about this bill. And one of the sponsors is Michelle Hinchy. Her district office is 845-331-3810. The other sponsor has had a tragedy in her family, and so we're not giving out her number. But phone Michelle Hinchy and your own assembly member, your own senator, and tell them what you think of this bill. You've heard two people who don't think this is a workable solution. And if you agree with them and you agree with several of the people who helped organize this, please let our state legislators know. So it's important that we don't encourage false solutions. If you have better ideas, maybe there's a way to start paying people for preserving their forests. And that would be a very nice solution for all of us who grow trees. So thank you to everyone, and thank you especially to the sanctuary for hosting this, and for everyone who helped to organize it. Good night to everyone, and we'll end it here. Thanks, everyone.
Thank you. Have a great night.
Thank you.